Hello everyone, good afternoon. So, in today's session, our agenda is priority queue. Okay, so we have to implement the program for when insert and delete operations on a priority queue. So, let's understand what is a priority queue. So, I'm sharing my screen. Hope you can see my screen. Can you see my screen?
Yes, sir.
Yes, sir.
Okay. So it's a one type of queue. Okay, a special kind of a queue. It is a queue, linear queue, where elements do have three major, three three basic components. Okay, like one is the data part containing information, some value. Okay, so in case of a queue, every element does have only a single component, that is the data, and that data is to be inserted at some position. That position is always at the end. If you think implementation of a linear queue using a single linked list, so that new value should be added at the end of the single linked list, and the first node of that list should be deleted first, right? So that is the logic. And each of the element in linear queue does have a two component basically. One is the data part, another is the linker part. But if we don't think the linker part, basically each element in linear queue does have a single important component, which is the data part containing the main information, some value, some integer value. Data part stores some integer value, some float value, like that. But here, not only data part, but also it has another component, which is your the priority number. Okay, so which represents or specifies the priority of preference of the element to be processed. Okay, means an element is to be added, or I mean inserted, or deleted. What are the operations we can perform here? Operations, number one, insertion. We can do insertion, we can do deletion, and we can do traversal, means display. These are the three basic operations we can perform on a priority queue. You can apply more operations like counting, search, etc. That's not a problem. But these are the basic operations. Okay. Now an element can be inserted or deleted, right? So it is to be inserted or deleted based on its based on its priority. That is the important aspect of this special type of queue, which is known as priority queue. Okay. Now, if and there is another so data part, and there is a priority number, right? Another third part is the order number. Okay, which specifies which breaks tally tie between two elements having same priorities. So if two elements have same priorities, then they are processed. Here process means, in your context, process means insertion or deletion. So they will be inserted or deleted based on their order. Okay. So this is the thing. And one example I just want to show you to understand here. So already I have shared this to all of you. Hope you have seen that, studied that. But still I am repeating this. Aisha ma'am, are you there? Yes, no? Okay, no problem. So illustrate the insertion of a given sequence of data in a priority queue. So here 5 elements are given in this order from left to right. So first this element will be inserted, then this data will be inserted, then this element, and then this element. So if these elements are getting added, right? Insert several elements from the in the priority queue. Now the question is, if it is a linear queue, so this is going to be the first element, this is the second element in the list, this is the third element, fourth element, and fifth element, isn't it? First I am adding this element to the queue, so this is going to the first element in the queue. Next I am adding this. This is the sequence. In this order, you have to insert the elements into the queue, priority queue. But if it is a linear queue, this should be the first element, and this should be the last element. Yes or no?
Yes, sir.
Right?
Yes, sir.
Right. But the difference in case of priority queue is this. So where when these elements, though though you are sequentially trying to add them in this order, first this, then this, then this, and then this, and then this, but after adding them or inserting them, you will see that this may not be the element positioned at first position in the list. This may not be in situated at the last position of the list of the queue. Okay, because each of this element data is represented as a triplet, where the first triplet means a single entity contains three kind of information, three kind of values. That's why it is called a triplet. Okay, so first value, the first part is the data value, second part is the priority number, third part is the order number. Okay. Okay, and here we want to make one convention ki, whenever we are trying to compare priorities of two elements, which one will be processed earlier and which one will be processed later, that will be decided by their priority numbers. That means you are comparing their priority numbers. So one of them will be less compared to the other, right? So if one is less, then it will be processed earlier. And if the priority number is higher, then means if the priority number value is higher, then it will be processed later. So this is one convention. You can do the reverse also. Suppose higher priority number means it should be processed earlier. Lower priority number means it should be processed later. You can also use that convention, but this illustration uses the former convention. Like suppose, oh sorry, it's a typo mistake, 7553. It should be 77, it should be 70, huh? So 753 is the element. The first part is the data value, that's the value data 70, but its priority number is 5, order number is 3. So as this is the first node of the queue, right? So it will be simply added to the queue. And as per the requirement of a queue, as it's a queue, so it should have two pointers, front and rear, and both of them should point towards this single node. Okay, so this is the picture. Next element is 63 and 5. 60 is the value, data value. 3 is the priority value, and 5 is the order value, order number. Now this priority 3 is being compared with the priority already exists in the list, in the queue, that is 5. Okay, so it has a priority 3 that is lower than the first node, this 5. So I said that in this problem we have used this convention. If lower the priority number, higher the preference, it should be given higher preference. Lower the priority value, it should be earlier, it should be processed earlier. ठीक है? So what has happened, it has priority 3 that is lower than the first node, so it will be added in front of 75.3, this element. So this is the picture looking like 75.3 pointing towards 63.5, and front is actually pointing towards this element 63.5, and rear is pointing towards 75.3. So this is now the first element in the queue, and this is the second element. You got it? It has the priority 3 because it has been given higher priority, and it has been given the lower priority. ठीक है? So front is pointing towards this, rear is pointing towards. So it becomes the first node in the element. This becomes the last element. Okay. Next element insert is going to be inserted is 51.4. So it has a priority 1, and that is lower than 3. So straightforward, it should be, this element should be added over here in front of 63.5. So front should be pointing towards this 51.4, and rear as it is 75.3. So after this is the picture. Okay. Next 25.4.1. So it has the priority 4 that is lower than 5, which is pointed by rear, but higher than the priority priority number 3. That means this element should be inserted in between this 5 and 3, so that the picture looks like this. So front is pointing towards, sorry, it should be 50 actually, typo again, mistake. So this should be the front and this should be the rear. Then 43.2, it has a priority 3 which is equal to the priority of this element. So this is one case where priorities are same. Okay, so it has priority 3 that is lower than 25414, but same as 63.5. So there are two options. 43.2 may get inserted in between this element and this element somewhere here where my cursor is highlighting, or somewhere here, right? Because you can put it here also, so that its priority 3 is more than this priority. So ultimately the logic is, lower the priority value, it should be towards the front side of the queue, and higher the priority values, they should be kept towards the rear end of the priority queue. That's it. So see, already they are getting sorted. In this situation, 1, 3, 4, 5, they are sorted in terms of their priorities. So it will be processed first. Then this third priority number data will be processed first. Then this fourth priority will be processed first. Then fifth. So lower the priority value, it is given higher preference. It is placed towards the front end of the priority queue, and higher the priority values, it's given lower preference and placed towards the rear end of the priority. But here,
আচ্ছা স্যার, তাহলে প্রিন্ট করার সময় আগে 40টা প্রিন্ট হবে, তো 40 তারপরে 60 এইভাবে প্রিন্ট হতে থাকবে।
যেভাবে প্রিন্ট করো, ultimately my question is, this should be the first element to be processed front, and this should be the rear. তুমি এদিক থেকে প্রিন্ট করো, এদিক থেকে প্রিন্ট করো, doesn't matter.
ওকে স্যার।
Okay, but ultimately you have to make people understand that this is the front end and this is the rear end. ঠিক আছে? Anyway, so now this is a situation where this is having a priority same as this element, so they are in a tie. So to break this tie, this order number comes into its role. Okay, so let's see what are their order numbers. Its order is 5, its order is 2. So what happened? 63.5, this. Okay, so this element 43 will be added here in front of 63.5. Why? Because its order number is lower than this order number. Similar logic, whatever we have applied. See, priority value 1, 3, 4, 5. In this way, front to rear, the priority values are increasing. Similar thing, if it happens that priorities are same, 3 and 3, then from front end to rear end, the order number should be increasing. So 43.2 will be placed over here, somewhere here. So this should be the picture. So they have same priorities, 3, 3, but it is placed in front of this because it is having lower order number, and this is having higher order number. Lower the priority, higher the preference. Lower the order, higher the preference. Both trend we have used here same. Okay? So this is one illustrative example. You can now start the program, and you can use this test case to validate your program.
Sir,
if you have any question, you can ask.
Sir, I have questions.
Yes.
স্যার বলছিলাম যে আমরা ডেটা ভ্যালুটা তো ইউজারের থেকে নিচ্ছি, তার সাথে আমরা প্রায়োরিটিটাও নিচ্ছি। তো আমি যদি ওখানে একটা প্রিন্টফ স্টেটমেন্ট দিয়ে দিতে পারি যে নো টু এলিমেন্টস ক্যান হ্যাভ দি সেম প্রায়োরিটি, তাহলে তো অর্ডার নাম্বারটা কনসিডারেশন করতে হবে।
No. Priorities, see, this is the functionality. Elements may have their priorities same.
তাহলে অর্ডার নাম্বারটা ইউজার ইনপুট নেবে?
হ্যাঁ, পুরোটাই নেবে। ভ্যালু, ডেটা ভ্যালু, প্রায়োরিটি, অলসো দ্য অর্ডার, এখানে দুটোই নেবে, সবকটাই নেবে, তিনটেই নেবে। আর এইগুলো হচ্ছে যদি লিংক লিস্ট দিয়ে
বলতে পারো অর্ডার সেম হবে না, মানে প্রিন্টফ স্টেটমেন্ট
if you implement this priority queue using linked list, So you have to consider another part along with these three, that is the linker part. I have not shown this here, it's not, but actually linker part is there if you use linked list. ঠিক
স্যার
আছে?
আমাকে তো ইউজারের কাছে মেনশন তো করতে হবে যে অর্ডারটাও যেন সেম না হয়, নইলে তো স্যার স্যার তাহলে ওখানেও টাই হয়ে যাবে।
হ্যাঁ, অর্ডারটা যেন সেম না হয় এটা দেখবে। অর্ডার যদি সেম হয়, অর্ডার সেম যদি হয়েও যায়, অর্ডার কখনো সেম হবে না, মানে
হ্যাঁ
প্র্যাকটিক্যালি
স্যার,
হবে
এটাই
না।
বলছি।
ঠিক আছে,
হুম।
কিন্তু যদি সেম হয় তাহলে ওই মানে যে কটা মানে তখন কি হচ্ছে, দুটো পজিশন যদি অ্যাভেলেবেল থাকে ইনসার্শনের জন্য, তাহলে দুটোই ইকুয়ালি প্রবাবল, যেখানে খুশি তুমি ইনসার্ট করতে পারো, ইটস নট আ প্রবলেম। বাট সাধারণত অর্ডার সেম হবে না। ঠিক আছে, বাট হলে ওটা ওটা এই মুহূর্তে ওটা ইমপ্লিমেন্ট করার দরকার নেই। বাট হ্যাঁ, প্রায়োরিটি সেম হতে পারে, সেক্ষেত্রে টাইটা ব্রেক করার জন্য অর্ডার থাকবে, অর্ডার নাম্বারটা ইউটিলাইজ হবে। And this priority queue, I just want to mention, this priority queue is very important in terms of its application. One of the very popular application is job scheduling in operating system of a computer. So the digital computer processes the jobs, the tasks, various type of tasks based on their priorities. And priority queue finds its application over there. So in the next semester, there is a course which you will be studying, that is design and analysis of algorithms, where you will be studying more elaborately about job scheduling algorithm, etc., etc. Okay, so in that case, priority queue finds some very good application. That's why it is very important. And okay, job scheduling means, I mean, I suppose, let's consider a situation. Consider a situation means, let's say there are three machines. Machine one, machine two. Why this problem is? What is the problem actually all about? Let me uh, tell you about only the problem. Okay. Suppose there are three machines. Machine means three processors. These are three processors. Okay, you quad core processor, right? Octa core processor. So this is, let's say, three processors of there, three core processors, different, and each of these processors does have their own capability, means processing time. So they have their own processing times. So TP1, it is having its own processing time. TP2, processing time means uh, it's the, I mean, is the time taken by that processor to complete a unit amount of tasks. ঠিক আছে? So that is the processing time, you can say TP1, TP2, TP3. And now you have several jobs. Let's say job 1, let's say job 2, okay, then job 3, and then job 4, then job 5, job 5. So there are 5 jobs or 5 tasks, and this 5 tasks is to be processed by this entire computer, which is having 3 processors. ঠিক আছে? Now each of these jobs have their own priorities, and their who give these priorities, preferences. So for that purpose there is an algorithm which is called job scheduler algorithm. There should be a job scheduler in your operating system who prioritizes the jobs in terms of their priorities. Okay, so each of these job does have its own priority. Okay, and also each of this job is specified with its own processing time. I mean, let's say job 1 takes 2 unit of time to be completed, its performance, and it is having some priority. J2, job J2 is having some priority, and it is specified with its own processing time, let's say 4 units. So it takes 4 unit of time to be completed in that way. So every job is specified with its priority, and also the time taken to be finished. So based on that, So these jobs are now assigned to this computer. So as there are three processors, the question is which one or which set of jobs this job scheduler will assign to machine 1, processor machine 1, M1, which set of other jobs will be assigned to M2 processor, and which set of jobs will be assigned to M3 processor of the computer. Okay, so let's say job scheduler assigns to machine 1 job number 2 and job number 3 based on their priorities and time to get finished. ঠিক আছে? Next, in machine 2 M2 processor, let's say job 1 and job 4 is assigned, and in processor M3 job 5 is assigned. So M1 will take some time based on its TP1 processing capability. Let's say that is the actual time of operation. Let's say T1. M2 takes some time T2 to complete the jobs J1 and J4. M3 takes some time T3 to complete the job J5. So what is the total amount of time the computer has, I mean, has taken to complete all the tasks? Okay, so we can say that let's say max, okay, sorry, not summation, we can say that TC completion time is equal to, let's say, max of T1 comma T2 comma T3, because they are all parallel processors, means all the scheduling, when all the processors are performing or doing the jobs parallelly. So it's a parallel architecture, not a serial. And most of the modern day computers do have parallel computers, parallel architecture. So T max of T1, T2, T3. This gives us the actual completion time, which defines the performance, the speed, processing speed of the overall computer. My computer is slow, his computer is fast, like that, right? Now it depends on T1, T2, T3. And T1, T2, T3 depends on what kind of jobs are being assigned to M1, M2, M3 respectively. But if you, so that means there are several possibilities. So this is a problem. So this is a problem, how these jobs will be assigned to M1, M2, M3, right? So this is one set of combination. This is one combination. So J1, J2, J3 is assigned to this. J1, J4 is assigned to this. There may be other combination where you can assign J1 only to M1, J2, J3, J4 to M2, and J5 to M3. So there may be several combinations, other combinations, many combinations, right? So this TC, we can say, is not a unique thing. It depends on what kind of combination is being applied to the parallel processors. But TC depends on that combination. So let's say this is the ith completion time corresponding to the ith combination. This is the ith combination. There may be other combination also, right? So what is the problem now? The problem is to find the job scheduler, or it is to, the problem becomes is to find the minimum TCI, right? There may be several TCIs, out of which whichever TCI is the minimum, you will consider that TCI, and corresponding to that TCI, you will assign the particular combination to the parallel processors, right? So the problem is to find minimum of TCI. TCI. So argument argument means you have to find that combination, find the combination, find the combination. Why this job scheduling is so important? Find the combination for which for which for which TC optimized becomes equal to minimum of TCI. That means in next step we can write TC0 TCO, optimized computational time of the computer. Okay, so it's an optimization problem, it's a combinatorics optimization problem. So TC0 is equal to mean of max of TR1 T2 dot Tn, right? So this is the formulation. So it's a very popular, well-known combinatorics optimization. It's an optimization maximum. Anyway, so this finds, so how to find the appropriate combination, which is possible by an appropriate job scheduling algorithm, and which data structure requires is which data structure you will use for this job scheduling purpose. That is the priority. That's why today's experiment finds a very important application in practice. Okay.
স্যার ওয়ান
Yeah.
কোয়েশ্চেন, স্যার বলছিলাম যে দুটো প্রায়োরিটি যদি সেম হয় তো
হুম।
স্যার অর্ডারটা আমরা কম্প্যারিজন করবো, তো অর্ডারটা যদি স্যার স্যার যে যে এলিমেন্টের অর্ডারটা কম হচ্ছে মানে ছোট হচ্ছে তাহলে সেটাকে আগে ইনসার্ট করবো, তাই তো? মানে স্যার অ্যাসেন্ডিং অর্ডারে এগোবো,
হ্যাঁ, যেটা কম হবে সেটা
আগে ইনসার্ট করবো।
আগে
হ্যাঁ
ঢুকে
মানে
যাবে,
হ্যাঁ 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 ঠিক আছে।
কিউতে আগে দাঁড়াবে।
হ্যাঁ স্যার।
লোয়ার দ্য ভ্যালু, ইট শুড বি প্লেসড টুয়ার্ডস দ্য ফ্রন্টের দিকে চলে যাবে। ঠিক আছে?
হ্যাঁ স্যার হ্যাঁ।
সেদিকে আমি এদিকে ফ্রন্ট ধরেছি, এদিকে রিয়ার ধরেছি। আর কোনো ডাউট? Okay, so I think we are done.